Hi everyone, I told you I was going to go through question number 3 from our first quiz, since a number of students struggle with that. So I just wanted to go through the solution here rather than just give you the key, show you how to solve it. So this is basically a combination of a conversion problem as well as a dilution problem. So you have an initial solution which is 100 ppm of serotonin. We have a molecular weight here. And it says how many microliters of this are required to make 10 milliliters of a 1 micromolar solution. So a couple of things are going to be handy to understand this, and one is to know our different prefixes here. And in particular, I mentioned before that the ones you really want to focus on having a good grasp of are these ones that are around the thousands. So we've got kilo and milli and micro. And at some point I think I should also know nano, because that shows up a lot, particularly when we talk about spectroscopy. But basically we're talking about 10 to the 3, 10 to the minus 3 for milli, 10 to the minus 6 for micro, 10 to the minus 9 for nano. So just having that in your mind are good things to have. Okay. So another thing that helps is to really understand what ppm means. Now, we talked about this in the video. This is a common unit in analytical chemistry. So ppm, right? If you remember, ppm is we're at 1 million per 1. So that would be 1 times 10 to the minus 6, right, per 1. These are 10 to the minus 6 grams per gram. If you think about this in terms of this, if we're dealing with a solution, right, 1 gram of water is just 1 milliliter, so this would be 1.0 times 10 to the minus 6 grams per 1 milliliter. And one thing that would be very handy for us, because we're going into molar solutions, and molar by convention is usually in liters, so that's this 1.0 times 10 to the minus 3 grams per 1 liter. Alright, so we just multiply both these sides by 1,000 to get this, so this is going to be important. Okay, so that's those of ppm. So if we know we have 100 ppm serotonin, right, then that would just be 100 times 10 to the minus 3 grams serotonin. I'm just going to call this ST, serotonin, per liter. So if we want to find out how many moles that is, I mean, you could also, this thing's also equal to 0.00 times 10 to the minus 1, right, if we're just moving the decimal point over, per liter. Either way, these are both mean the same thing, right? And so we want to convert that into molar units. So what we'll do is we'll say, okay, we know our formal weight here is 176.2 grams per 1 mole. Right? So if we do that calculation, we get something like this, ends up being 5.67 times 10. Oops, I'm out of space here. 10 to the, dang it. Okay, let me fix that. Alright, sorry about that. Alright, so let's try and write more cramped here. 5.67 times 10 to the minus 4 molar. Okay. And if you recall from our prefixes, right, a micromolar is 10 to the minus 6. Okay. So in order to figure out, we're going to use our handy handy equation that we use a lot, which is M1V1 or C1V1 equals C2V2, right? Concentration times volume equals concentration times volume. In this case, we know, right, our what we want to get here, our C2 is 1.0 times 10 to the minus 6 molar, and our C1 is 10 milliliters. So you can do this a couple different ways. depending on which units you're most comfortable with. But I'm going to start out with C1 is 5.67 times 10 to the minus 4 molar. I'm going to multiply that by V1. That equals, say, 1.00 times 10 to the minus 6 molar times 10 milliliters. So, and again, 10 milliliters, if you want to convert this into liters, you can do that too. Either way will work, and that would be 1.00 times 10 minus 2 liters. Okay, these are both the same thing. Okay, so if we go through, basically we multiply these two together, divide by this to get V1. Get V1 equals 1.76 times 10 to the minus 2 milliliters, or if you use this one instead, 1.76 times 10 to the minus 5 liters. Okay. And so it's important to remember our prefixes. Remember that micro is 10 to the minus 6. So this, right, milliliters is just, oops, yes. This would, if you thought about this in terms of milliliters, this would just be 0.0176 milliliters. Okay. Which, if you think about that, right, if you sort of move the decimal back 3 points to get to microliters, that's right there. And so this would equal 17.6 microliters. Okay. And if you go through here and you look at this from liters, right, from liters to microliters is 10 to the minus 6, and so this is just 1 order of magnitude greater than that, so this is just 17.6 microliters. So either way you go about it, you get to the same answer. So hopefully that worked out for you guys and made sense. Let me know if you have any questions, but again, a lot of this probably, I think a lot of people ran out of time, but the important thing is to understand what ppm, how you translate ppm into grams per milliliter, or this is actually a milligram, so that's a milligram per liter, right? And then also to be able to understand the relationship between micro, milli, and the non-prefix version of it. So hopefully that makes sense to you guys, and see you in class soon.